Now, you already learned about the loops in your programming class. Yes, loop is a control structure, which and then life itself is a loop. Yes, we had winter, now we have spring. Yeah, yeah. Create a new thread. Or I can create a new thread for you guys. Yeah, okay. Answer to exercises of week, and then you would post as a reply. No problem. Yeah, okay. Okay. So loop are, and then there are different the types of the loops you probably heard about. Count controlled, meaning you know how many times it happens. It's counter. There is a counter. Yeah. But then there is another one which is condition controlled. Yeah. And then our life is a big loop. Yeah. Like it's like spring, then winter, spring, then summer, then winter. No, spring, then summer, then fall, then winter, then again spring. Yeah. So that's why loops are very important. And then you would sometimes even infinite loops, which are used to assure a program segment loops forever or until an exceptional condition arises. But basically, we shouldn't have algorithms should be finite. So that's for sure. Now, if you did code.org, you would actually recognize this. Yeah. So if you have a condition, while condition is true, so what does it mean? It means, for example, while it is sunny, go around and enjoy the weather outside. Yeah. Okay. And then there is another type with condition, which is repeat until. So you repeat something until the condition is met. So do it until something happens. Yeah. If you watch the videos there in code.org, there is a nice video with the NBA basketball star. He says that I would repeat the same movement until I kind of score 10 balls in a line, in a row. Yeah, okay. If you can, for example, score 10 balls in a row, it means that you should stop training for today. You are good. Yeah. But then the counter thing is that you actually have, how many times the action should happen. Yeah. So it would look a little bit different. Yeah. You would say sometimes from number 8 to, for example, you can say, do these things 10 times. How you do that? Start from 1 to 10 or start from to 9. Yeah. There is one of the actions which is modularization. It's very important element of programming. You probably already learned that. It's basically about creating, putting your portions of your algorithms into a box and naming it a sub-process. So there are so many activities which can be called many times. And instead of kind of repeatedly writing them down or putting them together, you would actually create a sub-process as a module and then call it, and we call it from other different parts of your computer program. Now, you probably already know it from the programming principles course. How we call them in C? What are these modules? And then these modules would have input, which would be called formal parameters. Yeah. And then what's that? Anybody who would know the answer? Oh, come on. We are talking about sub-processes, modularization, calling some sub-process. What's that? Not formal parameters. Functions, guys. Functions. Basically, immediately when you see this pseudocode description of that, you probably immediately recognize that. So basically, you would need, and then in parentheses, you would have number of parameters. So basically, you would call some portion of algorithms with a name, and then in another place, you would basically, you would be able to write name, and then this sub algorithm would be called. And then you can see the example from our code.org kind of model. So you can see that actually you can put together a nice sub-process of drawing a cycle. You can call it draw a cycle, and then you would actually, you know, call it, and then the parameter would be step, and then you would basically call it from your main program with a number passed to your parameter, and as a result, you can see the step is used here. Yeah, okay. So it would define actually how big is your circle. Yeah. There is a nice notion if if you think about general functions, there is a also nice notion of recursion we need to touch upon. But then, have you seen this demotivator, guys? So have you seen that one? And anybody who saw it? So basically, the guy is giving a hint like it's 12, but then instead, anybody knows what is this? What is this? 12 in mathematical sense. Factorial, exactly. Factorial. Anybody heard about, anybody didn't hear about factorial? Yeah, so basically 12 factorial is something like 1 multiplied to 2 multiplied to 3 multiplied to 4, etc., multiplied to 12. And then poor guy is kind of finding, and there is even another demotivator which is working on that. So basically the guy would find the factorial, then he would go down to the solution. So it's like there is a Azerbaijani saying, scratching your left ear with your right hand. Yeah. Okay. Sağ elinden sol kulağını kaşımak. Now, there is a beautiful notion of recursion. Did you learn it in the programming principle already? It's a very, very deep notion, and it's not only about programming, but then recursion is when a thing is defined in terms of itself. Now, let me give you one example. Recursive definition of person's ancestor. Ancestor, do you know what's that? Ajdad. Ancestor. So X's ancestor is either a parent or parent's ancestor. You see, in definition of ancestor, you use itself. Okay. I would urge you to think about examples of that in your daily life. Yeah. Does it make sense to you guys? So somebody's ajdad, somebody's ancestor is your parent or your parent's ancestor. Yes, Hussein, question or answer or what?
May I tell example of recursion?
Yes, but then if it is from real life, go ahead.
Yes, it's from real life. For example,
Go ahead.
if you will share, if you share your screen and it will keep the Blackboard page, so every time it will go in the recursion and show your desktop, because every time it share.
Okay, that's a beautiful, visually beautiful effect you would have. Actually, you are standing in between two mirrors. But then what we were talking about, defining some notion, which is like, for example, ancestor, using the notion itself. Okay, but then I would agree that Hussein's kind of definition is like when you have inside the same thing inside of that, there is certainly a link with recursion. But then I was asking about like definition of something with, you know, using the thing itself. Yeah. Okay. I think this is a beautiful example. Think at home about other examples. Okay. But this and then in math, in calculus, you will see recursive formulas or definition of something in recursive way. And in programming, basically we are using it. You will use it a lot. It's very powerful, beautiful mechanism. So recursive behavior can be defined by two properties: a simple base case. So usually you have a case which is base case, a terminating scenario. So basically after that, in base case, you don't need to actually go and do another recursion again, and recursive step. So in definition of ancestor, the base case is that if this is parent, so you don't need to think more. Yes, for example, your father is your ancestor, that's it. Yeah, but then if you think about some more ancestors, you need to go deeper. Okay, what about, like, what about your grandfather? He's ancestor because he is the parent of your grandfather. And then why grandfather is ancestor? Because the grandfather is father of your father or mother or whoever, if we talk about father side. Yeah, okay. So that is how it works. Now, you would say, what is in it for us, Aras madam? Why we talk about it? Now, in programming, there is a notion of recursion too. In fact, we just together with Ali and Nihad, we defined n factorial, but then you can also define n factorial using recursion. And you probably heard about it in mathematics.